Polarization. Polarization is because if you remember my electrons, they are going up and down in my antenna. The result is that my electric field is going to be up and down, and that's why my wave was represented as being a line that goes up and down. So that's the electric field. The thing is that there is always two components to a radiomagnetic emission. There is this electric field, and there is also the magnetic field. And that makes that the signal has a direction. That's what we call polarized. So if this is your radiation, that could be, for example, the electric field, and that could be a vertical plane. There will be always on the side of it, and there is some finger exercise that you may have done at school if you work on the thing, but it doesn't really matter because what matters is that there is one, not exactly what finger is pointing to which direction. But there is always a 90-degree electric field to which is associated a magnetic field. So if your electric field is vertical, your magnetic field will be horizontal, and vice versa, right? Because the wave doesn't care where the Earth is. It's just that as there is one component that has one direction, at 90 degrees of it, there is the other component that has the other direction. So if electric is horizontal, magnetic is vertical. If electric is vertical, magnetic is horizontal. So that's what polarization means, that there is these two directions that you need to be aware of. Why do we care? Well, we care because if you are sending a signal and your antenna is sending the electric component vertically, what you want is that that energy, that potential that goes up and down is received on the other hand exactly the same way, that is to say with an antenna that is also vertical, so that the electrons inside that antenna are going to be able to move up and down with that potential. Because if you do not, if you send a signal that is up and down electrically and on the other side your antenna is horizontal, what is going to happen is that the electrons in that antenna are going to be moving sideways. They are not going to be transferring anything to the circuit because simply they should be going left and right instead of going up and down to be able to move in the right direction. So that is going to be creating an effect where your signal on the receiving end is going to be very weak because it doesn't have the right polarization. Typically, we say that outdoor, if you send a signal that is electrically polarized vertically, and if the other end is not electrically polarized vertically as well, you may be losing up to 20 dB by using the wrong polarization on one side. Using vertical on one side, horizontal on the other side, you lose up to 20 dB. So that's very important outdoor. Indoor, that is not important. Why? Because the signal is going to bounce around anyway. So at any point in space, you will have a multitude of components that will be reactions and result of reflections everywhere with all sorts of strength and all sorts of polarizations anyway. So polarization is not that important indoor. However, it doesn't mean that you shouldn't care about it. You should do your job right. And if you have a polarization system, and typically Wi-Fi uses vertical polarization, you should make sure that your antennas are vertical if they're supposed to be sticking out of your antennas. Up and down, right? They can be up and down, doesn't matter, but they have to be vertical so that you have a right polarization right from the beginning. If it's not that way, it's typically not critical, but it's better if it is.